.NET Core has built-in dependency injection that we use in every web project type we create. However, did you know that you could also use the same dependency injection in the .NET Core version of WPF? In this video, we're going to enable dependency injection in WPF and then use it for some common scenarios, including creating multiple forms. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I do that by providing videos here on YouTube multiple times per week, plus I have a weekly podcast called Dev Questions. I also provide courses on C#, web development, and much more at IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube, so that everyone can have a great education in C#, not just those who can afford it. In this video, as with most of my videos, I'll create some source code. If you'd like a copy of today's source code, use the link in the description to get it. Okay, let's go to Visual Studio, and we're going to create a new project. And we're going to choose a WPF project, so WPF application. This is a .NET 6 application. Now, if you have the .NET Framework templates installed as well, make sure it does not say .NET Framework in parentheses. Okay, so you'll see down here, WPF app .NET Framework. Don't choose that one. Choose this one. Hit next, and we're going to call this DI in WPF, and we'll say DI in WPF app. And we'll hit next, and we're going to choose a .NET 6 version. So it says .NET Core. .NET 6 is actually .NET Core. Just drop the core name, but it's .NET 6, which is the latest version as of the time of this video. But if you're on .NET 7 or beyond, you can still use that. But it's up to you if you want to choose .NET 6 or the latest version. Hit create. And when you do, we'll get a pretty typical application. Now, we're going to do a little bit of cleanup on this because it's a little messy at first, but let's first start off by just hitting run once this is done building. Right now it says attach. Wait until it actually says DI in WPF. So we need to do a build here. Now it's built, and now it says DI in WPF. There we go. So you run this. It's going to start off to my other screen, but there's our WPF app. Not much to show yet. It's just a pretty simple app. The yellow border around here and this little thing right here, that's from Visual Studio because of the fact that we're debugging. That's kind of like, these are kind of like your tools you'd get in a browser, your F12 developer tools. That's kind of the same thing we can get with our WPF apps. We'll leave that minimized for now and hit close. Now let's go to our main window.cs. So main window.xaml.cs. It's got a lot of stuff in here we just need to clean up. Lots of usings. Let's get rid of them. We only need the system.windows. And let's put a semicolon after our namespace to make a file scope namespace. Let's get rid of our useless code comment. And that's what we're left with. This is the code that starts our main window. So it initializes the components that eventually becomes this page right here. We're going to modify this page in a little bit, but let's close both of these down for now, and let's understand how a WPF app actually runs. It does not start at main window.xaml. Instead, it starts at app.xaml. If we notice here, startup URI is main window.xaml. This is how you change it to a different window if you want a different window to be the starting point of your application. Now for us, what we're going to do is get rid of this entry right here. We're not going to have a startup that starts here in this XAML code. Instead, we're going to go to the code behind for app.xaml, which is app.xaml.cs. This is where, again, let's clean up the useless code comments and all the using statements we don't need and make this a file scope namespace. But this is the true starting point of our application. There is no program.cs, unfortunately. It really should have one, I think, but it doesn't. So we have app.xaml.cs, and that's the starting point of a WPF application. So it's in here that we'll do our work. So inside this public partial class app, we're going to say public static iHost and control dot to, well, we don't have even a using for this yet. We're going to have to add a NuGet package for that. We're going to do it in just a minute. App host, and we'll make this a get and a private set. So this is going to be a static property which we can access anywhere. So we're going to set this up in just a minute. We also make it nullable, meaning it can start at null. But we need to have this iHost, which is actually part of dependency injection. And to do that, we have to add two NuGet packages. Right-click on dependencies, manage NuGet packages, browse. And in here, we're going to say Microsoft.extensions.dependency injection. That's one. And we also need, hit OK. We also need Microsoft.extensions.hosting. Right there. So we need these two. They're from Microsoft. They are they're NuGet packages that support .NET. Now you may wonder, well, why isn't it installed right inside of .NET Core itself? Like, why is this not part of .NET Core if it's actually truly part of .NET Core? Well, the reason why is because they did that in .NET Framework. So .NET Framework had everything inside the framework. The problem was we didn't need everything all the time. And so with .NET Core, they took the opposite approach, where they said, let's put only the stuff in .NET Core itself that everything needs, and then anything else we'll break apart into a NuGet package, still supported by Microsoft, still a part of .NET Core, but this way you can only bring in the pieces you need and make for a more performant, smaller version of .NET Core than we have a .NET Framework, where we brought everything, including the kitchen sink, along with us. So we now have two NuGet packages installed, Microsoft.extensions.dependency injection and Microsoft.extensions.hosting. These are two that come from Microsoft that support what we're trying to do. So here you can hit Control dot to add that using for Microsoft.extensions.hosting. So now that we have this set up, we have what's going to be our host for our application. Let's talk about how to configure this. Let's create a constructor. And in here, what we're going to do is say app host equals host dot create default builder. If you're familiar with how to work with other applications such as Blazor server or ASP.NET Core MVC or whatever else, you'll see something like this a lot, the create default builder. And this is what sets up things like, and it has a listing here, iConfiguration, iLogger, and it even sets up the system to be ready for dependency injection. So there is our default builder. And then from here, we can say, let's put enter key. We don't put a semicolon yet. We're going to continue to extend off of this. We're going to say dot configure services. And then we're going to say, we need two things in here. We need host context and the services. And we're going to have our curly braces here. Inside our curly braces, we'll have some code. So let's do it at the end, though, dot build. So what we have here is we have our default builder. We've set it up. It has iConfiguration. So we have app settings.json. We can have app settings.development.json, secrets.json, all the rest. We can have iLogger for logging our application. And we can also configure our services. And that's what we're doing right here. Our services are dependency injection. Now, once we're done configuring our services, we build this. Now, we don't have any services yet. We'll come back to that in a minute. But we're going to say now build. And that's going to build this app host. Remember, we're assigning this to app host. Now that we have it built, we need two more things. We need, and I'll explain more with this as we'll come back to this. So protected override on startup. Now we're going to mark this as async. So we have protected override async void on startup. And what this is going to do is we're going to start up our application. But before we do the base on startup, we're going to await app host dot start async. So we're going to await the start of our container. Now it's going to say, hey, that may be null here. We know for a fact it's not null. That's the exclamation point takes care of, because of the fact that we have created it in the constructor. So we've created it right here. Therefore, it's never going to be null once we start using it. So we can say the character here that ignores this warning. Now, I covered this more in my video on nulls. So if you're not familiar with that character, go watch my video on nulls, because that will enlighten you as to why we're doing this. It's really a design time thing where we're talking about just telling the compiler, hey, ignore this warning. It's not really going to be nullable. So we're going to start our application. So we built it here and put it here. But this is where we actually start the application. And then we're going to say var startup form equals app host dot services dot get required service control dot to add that using for dependency injection, and we'll say main window, and then startup form dot show. So what is this doing? Well, once we start our container, we still have to have an entry point to our application. And the way WPF applications work, and it's kind of the same way that WinForm applications work, is that the starting point is your first form. And that form closes down, the application closes down. So we need to start the first form. And that's this right here. We get that form from dependency injection, and we show it. And then we're good to go. We also need one more override. So protected override on exit. So when the application exits, we're going to first, and let's make this async. We're going to first await app host, which we know for a fact is not null, dot stop async. So when we exit the application, we'll stop the app host. And then we'll do the rest of the exit things we need to do. So we have now configured our WPF application to handle dependency injection. Now, we haven't put it in dependency injection. We can do that right here. Services.add singleton and main window. And yes, I said singleton because we don't create more than one instance of our main window. There may be reasons why you'd want to create more than one. I can't think of any, because your main window is that window, again, that when it closes, the whole application closes. So you typically don't want to create multiple of those and create confusion. Typically, you want to create sub-windows or child windows, something else like that might have multiple. But for the main window, singleton is usually the right call for our application. So we've added that one service, which we're requesting right here. And if we were to run this, remember I took out that entry for the startup URI. If we run this, we still get our application launching. So it still runs, but now it's launching with dependency injection. And we can prove that this works with dependency injection. Let's start closing out of the things we don't need. Well, it's really just nothing, actually. So let's create, let's do it in a class library, just to show that you could use a class library. So right-click on solution and say add. This is still a sample kind of thing. It's not a, there's class library. It's not a real project. We're just doing sample stuff here, but let's create our WPF library. NES.NET 6, hit create, and we're going to delete class 1. And instead, we're going to right click and say add class, and we'll call this data access. And we'll get rid of all the using statements we don't need. We'll make this a file scope namespace and make it public. And we're going to create a public string, and we'll call this get data. So this method gets data, right? And it's going to return, this is the data from the data access class. Okay, obviously that's just sample. It's not actually going to SQL and all the rest, but that's the stand-in for what you would have for a data access class and a method. Now let's do a control dot to create an extractor interface into a new file. There we go. So now we have something to put in our dependency injection. So let's right click on dependencies and say add project reference, select the library, hit OK. And now we can come up here to our using statements and say using WPF library. And then down here, we can say services.add transient data access and data access, like so. Just like you would with a web application. We just add our services in the services area, and then we can request them. So in our main window.xaml.cs, we have a constructor, which, by the way, we've cleaned this up mostly. Let's clean up the rest of it. Let's ask for a data access, control dot to add the using, and we'll say data access. And we can say control dot to create and assign a field. And now let's go to our main window.xaml, and we're going to do some really quick and dirty stuff here. Let's first of all trim this down to a more usable size. Let's do I don't know. Let's do 300 by 500. I'm going to put a stack panel here. And the orientation is vertical. And let's do the horizontal alignment as center, and vertical alignment is center. So you got a stack panel, and now put it right in the middle of form. Again, really quick and dirty, but we're going to create a button here. And we're going to say that the X name of the button is get data. Get data. That's fine. And we will say get data. Of course, that button's really tiny. So let's say that the, let's change the font size overall for application. So up here, we can say font size equals 22. 24? Yeah, 24. And we'll say that the margin is actually padding, right? Padding is 20. There we go. Just something. 2010, there we go. Better. So we got a button. It looks like that. It says get data. And then what we'll have is we'll have above this, we'll have a text block that has a name of data. And that's it. Yeah, that's it. So it's going to sit above the button, and it's going to have this, the name of data. So in our code behind, let's actually double click on our button, which creates the event. And we can say data.text, that's our text field, equals our text block, equals data access get data. All right, that's it. Let's run this. Make sure it runs. It seems to. There we go. Get data. Click it. This is the data from the get data or get from the data access class. Boom, done. So we've got data from our data access class using dependency injection. So in our main window, we have said, give me an iData access, and then used it. So that's dependency injection. We've just requested it, and it's just happening because of the fact that when we create our main window, it says, I depend on iData access, which is, okay, there's the implementation, pass that into main window when you construct it. Now, that's just basic data access or basic dependency injection in WPF. We're done. We're working. That's all you really need to set up dependency injection. Well, almost all you need, because there is one more thing you need to think through, and that is, how do you register your forms? Because maybe you have another button. Let's create another button here. Let's copy this. And we'll take off the on click. And we're going to change this from get data to open child form. How about that? And we'll say open child form, like so. And we want this button to open a new form, which I don't have yet. So let's right click on the project and say add. And we'll say new item. And we're going to say a window, WPF window. We can also do page or use control. We're going to do window. And we're going to say child form is the name. There's our child form. And if we come down here, let's make this, let's make it smaller. Let's go with maybe 200 by 500. Something like that. And then we're going to create another stack panel down here. So you have it, and orientation is vertical. And let's have a text block here that has, let's create a font size up here of 24. Text block is this is let's call it the child form. Just to have something there. Let's also make this the horizontal alignment equals center. There we go. So it says child form. That's all it does. But we want to open this child form, and maybe more than once. So how do we do that? Because we could put it in our dependency injection, like we have main window, where we say services.add transient and say child form. But how do we get more than one form to open? So if we go over to our main window.xaml and double click on this open child form, if we were to ask for a child form, control dot to create a sign up field, we could say child form dot show, but that's only going to open one form. So if you run this right now, and it's going to open the other screen, and actually the form is too, but open child form, and that open a child form, I click it again, nothing seems to happen. I keep clicking it, nothing seems to happen. It only opens the one form. But what if I wanted to have multiple forms opening up? Well, I can't do it this way. So if you watched my video on the factory pattern, that's going to be very, very helpful here. So let's create a abstract factory. So let's do this inside of a form or a folder. So let's add a folder. We're going to call it startup helpers. And inside here, we're going to add a class. And we'll call it abstract factory. And we'll put our semicolon here and get rid of our usings and make this public. And in our abstract factory, we actually want it to be of type T. We want it to be a generic factory. We want to say constructor. And inside of here, we're going to ask for a func of type T that is factory. And we're going to do control dot. Well, actually, to use system first. And then we do a control dot to create a sign-off field for factory. So now we have this func of type T, and we're going to create the public T create method where we say return factory, and we execute that function. So, or execute that delegate. So if this confuses you, and yes, this is confusing stuff, watch the previous video or a video I did recently on the factory pattern. This is just a generic factory. That's all it's doing. It's creating a generic factory which is going to generate for us our forms for us. Okay, so now we have our generic factory. What we can do is we can create let's create another class in here. And let's call this class service extensions. And again, get rid of the using statements. And yes, put your semicolon here and make this a public static class, service extensions. So we're going to do some extension methods here. And the extension method we want right now is public static void add form factory. And we're just going to ask for the implementation, or just T form, and say this iService collection, control dot to add the using for the dependency injection, services. And we can ignore that error. So what that's going to do is create for us a factory that will generate our forms. Now, I did not ask for an interface and an implementation like I did in the factory video, because in this case, I just want the implementation. We don't typically create our forms with interfaces. We could. You absolutely could, and you could still follow the same pattern of interface and implementation. But in this case, we're just going to do the implementation. I am going to put a where clause here where T form is a class. So let's just limit it to a specific class. And then we're going to say services dot add transient, the form. So you add the form as a transient. Services dot add singleton, a func of the T form. And then we're going to create that X arrow, open close parentheses, arrow X dot get service of T form, open close our parentheses, our semicolon at the end, and this is going to yell at us. Oh, func is going to yell at us first for using system. And this will yell at us because it says, hey, this could be null. But we know it's not, so we're going to use the exclamation point to say, nope, compiler, that's not going to be null because we just put that into dependency injection. We know it's not going to be null. And then we want to add our factory, which our factory, we just created the abstract factory. So services.add singleton, iAbstract factory, control dot to add that using. Oh, nope, because I didn't even create iAbstract factory. Let's do that. Control dot to extract the interface. Now we have iAbstract factory. So iAbstract factory of type T form. And then I have one too many closing right now. Abstract factory of type T form. Open, close, and semicolon. Let's put us opens up a little bit so you can, or move it a little bit so you can see the whole thing. So I've added 3 things to dependency injection. I add my form, which is a generic, whichever form we give it. I've added a func of that form, which is a delegate that's going to create that form whenever we run the delegate. So a delegate gets added to dependency injection, not just the form. So this is a delegate of the form, which means that this will get run whenever we run the delegate. And then we have our factory, our abstract factory, which the abstract factory will run that delegate right here on create. So with all of that in place, then we can come back to our app.xaml.cs right there. And we can save all this. We can add a using up here. Using our DI in WPF.startup helpers. Makes it easier because then we can say, instead of adding child form here, let's get rid of this. We're going to say services dot, and we called it add form factory. So add form factory for child form. Which what this does is it's going to add child form as a transient. It's going to add a func of child form that will run the child form or get the child form. And that's going to add an iAbstract factory of type child form to give us a child form. With all of that being said, we no longer in here ask for a child form. Instead, what we ask for, and let's change this now. We ask for an iAbstract factory, control dot to add the using, of type child form. We'll call it factory. Let's get rid of the child form here and the child form here, and we'll do the control dot to assign that field to factory. Now down here, what we can do is we can say factory.create and immediately show that. Now you could put in a variable and then do .show, but this will work just fine. Let's run this. Go over here. First of all, get data still works. Open child form, that opens a child form. Open child form again, that opens another child form. Open child again, it opens a third child form. These are all working with dependency injection. So they can have their own access to data access. In fact, let's do that. Let's close all this down. Stop. Now, you have to close all the forms right now because if a different form is open, it still keeps everything open. But once you close the last form is when it closes down. So now let's get into child form. And wow, let's clean up child form. Let's get rid of our useless comments there. We'll make it file scope namespace. We'll get rid of almost all of our using statements, just using.windows, system.windows. And in here, we're going to ask for our, I'm not even sure what we called it again. It was iData access. Let's just grab the same. Let's copy this. So we're going to ask for iData access and control dot to create a sign-up field. Notice I add a using statement up here for using WPF library. So we've now got data access, and we can actually just, we have our child form here. We have a text block that says child form. Let's create another text block underneath it and give it no text. We're going to give it a name of data access info. And then we can say data access info dot text equals data access dot get data. So right when it launches, we'll get the data. And we can run this. And now we have our get data, and that gets data. We open the child form, and it says this is data from data access class. So not only can we open multiple of these forms, not only can we can get our dependency injection from the main form, We can also use dependency injection in these child forms to get their own instances of data access. So this is how you set up data access in WPF. This is how you work with multiple forms if you need to generate multiple forms, from a button or something like that, where it's not from just the constructor. This is how you set up dependency injection in WPF with the .NET Core version, not .NET Framework version, the .NET Core version. So if you have any questions, let me know. If you need the source code for this, again, there's a link in the description. Let me know if you have any other thoughts. This was a suggestion from a suggestion site. So if you have a suggestion, go to suggestions.iamtimcorey.com, enter your suggestion, and hopefully you'll see that in a future episode here on YouTube. Thanks for watching, and as always, I am Tim Corey.